Hello, this is my presentation about volcanoes and how they work, how they types of volcanoes, the magma inside, and then all the igneous intrusions that occur. And the two images on the bottom there are two volcanoes that I took images of in Hawaii. The one on the left is on top of Mauna Kea, and the one on the right is next to one of the most active one right now. So my first two slides are about magma, and my first one is what is magma? First question. Magma is molten or semi-molten rock found beneath the Earth's surface. It's a mixture of hot liquid rock, suspended crystals, and dissolved gases. When magma erupts onto the surface, it's called lava. So when magma is only when it's like under the surface, uh, lava is only for magma on top of the surface. And what is felsic magma? Felsic magma is a type of magma characterized by its high silica content and high viscosity, making it less fluid and more prone to explosive eruptions. And the two slides I have on there, the two images, is just to show you magma because I couldn't really get an image of like magma surrounded by rock, so it kind of just looks like that. And then the other one is just, well, that one would be considered lava, but yeah, that's kind of what magma looks like. This slide is about mafic magma. Mafic magma is a type of magma characterized by its relatively low silica content and high levels of iron and magnesium. This type of magma leads to more like shield volcanoes because it's not as explosive. Because mafic magma is not as thick, so the air bubbles and magma coming up doesn't get trapped and bubble over, and that's what kind of creates an explosive volcano. So this one's more liquidy and flows out more just like water. This slide is about eruptions and the two different types, which is explosive and effusive. So explosive type of the eruption is uh, when trapped gases in magma rapidly expand and escape, blasting outward. And so what creates a explosive volcano is the mafic or the felsic magma because it's thicker, and the gases when they try to come out have a harder time doing so, which brings lava with them and like kind of bubbles over. So like let's say you blow a straw into like a milkshake, the that air has a harder time escaping than if you were to blow into like water, let's say. Um, Effusive eruptions, they're caused by when magma has low amounts of dissolved gases, and this is called mafic magma. So effusive volcanoes eruptions will have mafic magma inside, which is more liquidy, and for the gases, it's easier to escape. So the lava won't blow open and won't blow open the top, so it won't be as explosive. You see, so this creates shield volcanoes, which we'll get into another slide. This slide is all about the types of volcanoes. The first one is a cinder cone volcano, also known as a scoria cone, is a steep conical hill formed from loose fragments of solidified lava ejected during explosive eruptions. These eruptions typically involve a single, often cylindrical vent and result in an accumulation of pyroclastic material around it. The second type of volcano is a composite volcano, uh, and it also can be known as a stratovolcano. It is a tall conical volcano built up by many layers of hardened lava, volcanic ash, and other volcanic debris. These volcanoes are typically formed at subduction zones where one tectonic plate slides beneath another. The explosive eruptions characteristic of a composite volcano are due to the viscous silica-rich magma that characterizes these formations. The next one on the list is a lava dome. A lava dome volcano is a roughly circular mound-shaped protrusion formed by the slow extrusive extrusion of viscous silica-rich lava. These domes form when lava is too thick and sticky to flow far from the vent, causing it to pile up and solidify, often creating a steep-sided structure. These we saw a lot of in Hawaii. There's quite a lot of lava domes and hotspots like that. And on the very first page, you could see a couple of the lava domes. The next one is a shield volcano. A shield volcano is a broad, gently sloping volcano that is built up by successive eruptions of low viscosity fluid lava flows, primarily basaltic lava. These volcanoes are typically much wider and they are tall and characterized by their shield like shape. The one on the left, the image on the left, is a old volcano that erupted a long time in Hawaii, and we went to there, and we got to climb inside. Kind of cool, seeing all that melted lava, or the cooled lava, and that was a shield volcano that we climbed in. This one is about igneous intrusions. So it's the sills, dikes, batholiths, and Lakothlith. I don't know how to say that properly, but the two images on the left and right hand side, they're a little blurry because my shutter speed on the camera was really long and it was kind of hard to hold it still. But those two images are two images of lava tubes we got to climb in to, which was really cool to see. And you could see you couldn't see a lot because it was really dark, but you could also see some sills, like the melted or the cooled rock, the magma. I couldn't really get a good image though because it was so dark, but you could see a lot of that. And sills are basically a sheet-like body of igneous rock that has intruded between layers of existing rock, and it normally runs parallel to the existing rock layers. The next one we have is a dike. It's a volcanic dike is a sheet-like body of magma that forces its way into a fracture or crack in pre-existing rocks, cutting across the existing rock layers. The next igneous intrusion is a batholith. It's a large, irregular-shaped mass of igneous rock that forms when magma cools and solidifies deep within the Earth's crust. These formations are typically larger than 100 square kilometers in area and are composed of various plutonic rocks, like granite. The last one we have is the laccoliths. A laccolith is a type of igneous intrusion that forms when magma pushes its way into the Earth's crust, but instead of erupting onto the surface, it spreads laterally and forces the overlying rock layers to dome upwards, creating a lens-shaped or mushroom-like structure. The last slide is just a couple fun facts about volcanoes. Ash from volcanoes can spark lightning. The Ring of Fire contains 75% of volcanoes. Mauna Kea is taller than Mount Everest. That we actually hiked, or not hiked, but we drove up to Mauna Kea, which is the bottom right image. The sunset. We went up there for sunset, which is really cool to see the telescopes and the sun. And you're like 13,000 feet up, which I've never been that high, so it was kind of cool to be like all the way up there. But like from the base to the tip, Mauna Kea is taller than Everest, but from water level, Everest is way taller. So that's I didn't really know that. And volcanoes release water vapor for us to drink, and Olympus Mons is the largest volcano, and that is in our solar system, which is located on Mars, which is like 3 times bigger than Mauna Kea from base. So it's really big. And that's it for my project, my volcanoes project. So thank you, and thank you for everything this year, and I really appreciate everything, Miss Lagrange, and yeah, thank you.